Hey everyone, welcome back to my channel. In this video, I'm going to be continuing my data structures and algorithms playlist. This video is going to be all about the insertion sort algorithm, which is a really efficient algorithm for sorting a list. So basically, insertion sort is an algorithm where in an unsorted list, we find a number that's out of its place and then we compare it to the previous number. And then when we find the correct position for that number, we're going to shift all the other numbers to the right based on where the current number's position is. So when we do this sequence like many times, we're going to end up with a list that is completely sorted from least to greatest in ascending order. Now let's get right into the code. First, we're going to have a for loop that's going to be running the whole thing. And the for loop is going to be going through a range from 1 to the length of the list. So in this example 3, 1, 5, 2, the length of the list is 4. So it's going to be for num in range 1, 4. So here we're going to have two variables. Cur stands for current, and that's going to be the current number in the list. So for example, because the for loop begins with 1, so in the first iteration, in the first cycle, basically, the element is going to be 1 because we're talking about the first index, and the first index means the second element, and the second element or the first index of this list is 1. So cur is going to be equal to 1. Now pre is going to be the index of the number right before our current number. So our current number is going to be like the main number that we're trying to find. We're trying to find the correct position for it in the list. And pre is going to be the index of the number right before it, because we're going to be comparing the two numbers. And so that's going to be num minus 1. So in this case, num is 1 in this case, so num minus 1 is 0. So in the first iteration, pre is going to be 0. Okay? Now this while loop is going to help us compare our current number to all the other numbers, or whatever numbers in the list that we need to compare it to in order to find its correct position in the sorted list. So while pre is greater than or and equal to 0, so pre is kind of also going to be like a counter variable. We're going to decrement pre every single time in this iteration. So this way, we can find the correct position for the number. And as long as current is less than the number right before it, because in a sorted list, a number should never be less than the number before it. It should always be greater than the number before it. So as long as this condition is true, so we know that the list is unsorted. So we have to continue this while loop until we can find the correct position for that number. So here, nums pre plus 1, that means that so right now pre is going to be 0. So this means nums, and then we're going to take the first index of our list nums. And so our list nums over here is 3, 1, 5, 2. And so the first index is 1. So this position is actually going to be taken up by nums pre, and since pre here is 0, nums pre is going to be 3. So now what we're going to do is we're going to take our list over here and we're going to make it 3, 3, 5, 2. We're going to turn 1 into 3. Now the reason we're doing this is because we know that since 1 is this is not 1's correct position, because think about it, if 1 is less than 3 but 1 is also after 3, that means that this list is not sorted, because it should be 1, 3. It shouldn't be 3, 1, right? So we're going to take 1 and we're going to actually we're going to leave 1 hanging, because we have to compare 1 to 3 to find the correct position. So here we're going to turn 1 into 3, so now our list is going to be 3, 3, 5, 2. But wait, we're not done yet, because we still have to insert 1 back to the place. Right now we're just shifting all the other numbers 1 position up so that we can turn the first number into 1. This way the list can be sorted. So now we're going to decrease pre by 1, so now pre is going to be negative 1, because before pre was 0. So now since pre is negative 1, this loop is going to stop running, because this condition will now be false. Now we're not quite done yet, because again, this is not the correct sorted list. We still need to insert 1 back into the list. So now nums pre plus 1, so that means we're going to take the first index of nums, and that's going to be equal to current. So what we're really doing here is we're making our new list, which is going to be 1, 3, 5, 2. That's going to be our next, that's going to be our new list after this iteration is done. Now in the next cycle of this for loop, num is going to be equal to 2. So here, the current variable is going to be equal to the second index of nums. And since the second index of nums in our newly updated list over here is 5, so the current variable is going to be equal to 5 now, and that means that the pre-variable is going to be equal to 1, because 2 minus 1 is 1. Now, if you notice carefully, this while loop actually won't run, because 5 is not less than the first index of nums, which is 3. So since 5 is not less than 3, this condition is false, and that means that the while loop won't run. Now, this statement actually isn't going to do anything either, because this is just saying that the second index of nums is going to be equal to 5, which means that 5 here is going to be equal to 5. So nothing's really changed. So even if there is a sorted segment in the unsorted list, so if the unsorted list isn't completely sorted, for example, but there's still like some kind of sorted segment in it, that's not going to be changed. Okay, the rest of the list is going to be sorted accordingly, but any sorted sequence, like a sequence of numbers that's already sorted, that's not going to be influenced at all. Now, in our next cycle, num is going to be equal to 3, which means that current is going to be equal to the third index of nums here, which is 2. So current is going to be equal to 2, and pre is going to be equal to 3 minus 1, which is 2 as well. Now, here, nums, so the third index of nums is going to be equal to the second index of nums. So this is going to be 5. And now pre is going to be decreased by 1, so now it's going to be 1. And now again, since pre is 1 now, in the next iteration of the while loop, here, the second index of nums is going to be changed to the first index of nums. So 5 here is going to become 3. And so that means that our new list is going to be 1, 3, 3, 5. Now, again, if you notice carefully, this while loop won't run because current here is 2, and the 0th index of nums is 1, and 2 is not less than 1, which is why this loop actually won't, this iteration of the loop won't run anymore. So this loop, this list won't be changed any further. Okay, now here, nums, the first index of nums is going to be set to 2. So our new list is 1, 3, 3, 5. And so here, the first index is going to be 2. And now our list is finally sorted after 3 iterations of this for loop. And so here we have our sorted list. Just to double check, I'm going to run this. And as you can see here, the input is 3, 1, 5, 2. And the output is 1, 2, 3, 5. A completely sorted list. So I hope you liked this video. I hope you liked the code. I hope you were able to understand how insertion sort works and how it's efficient. So yeah, don't forget to smash that like button, subscribe to my channel, and share this video with your friends.